Hey guys, welcome back. Today is day 44, and we're going to be talking about direct and inverse variation. Again, only today we're going to add in word problems. Okay, so last class we talked about direct variation, and a direct variation is actually in the form of y is equal, your output is equal to your constant of proportionality times your x, and an inverse is y is equal to k divided by x. So with an direct variation, as your inputs go up, your outputs go up. They're proportional. And an inverse, as your inputs go up, your outputs go down. So it's inverse, okay? So let's go through a couple of examples of the word problems. So the first one we have, it says Hooke's law for an elastic spring states that the distance the string stretches varies directly as the force applies. If a force of 160 newtons stretches a string 5 centimeters, how much will a force of 368 newtons stretch the same string? Okay, so at first glance it seems a little confusing, but let's look for some key words here. So we see that the force is varying directly. As soon as we see this varying directly, we're going to think y is equal to k times x. Okay? Now, if you notice, the distance the string stretches varies directly with the force. Notice the distance is varying directly, so let's let d be equal to distance and F be the force, okay? So the distance would actually, if you think about it, the distance would be your output, okay? So this would be the distance and your force would be the input. So as the force increases, your output is going to increase. So the distance is directly proportional, varies directly to the force applied. So we're going to take our direct variation, instead of using our output y and input of x, we're going to make it make more sense with the word problem. We're going to use d and f. So the distance varies directly with the force. Okay, now the word problem is giving us some examples. It says if a force of 160 newtons, now the force is our F value, so right where the F is, I'm going to put 160. Okay, it stretches the string 5 centimeters, so the distance would be 5. Okay, I lined it up like this just so that you could see. So if we solve for k, we would actually just divide by 160, and we would get our k equal to 5 1/60ths, which is 1/32. Let's do it like this, 5 1/60ths, which actually simplifies to be 1/32. So we then take that constant in proportionality and we plug it back in. So our distance is equal to 1/32 times our force. Okay, so there's our equation. You can note that right here, we're on step 3. Okay, so it says then if a force, if a force of 160 stretches a string of 5 centimeters, so we got our constant of proportionality is 1/32, how much will a force of 368 newtons stretch the same string? Okay, now to do that, so let's just make a little bit of room here. Okay, so in order to do that, it's saying how much will a force, so our force is 368, so our distance would be equal to 1/32 times 368, okay, because the word problem is telling us to let our F be equal to 368. Okay, we just plug it in, and then we find out the distance when we multiply is going to be 11.5 centimeters. Okay, so that's all spelled out in the steps above, but I just wanted to kind of walk you through it. So that's an example of varying directly, or a direct variation. Also keep in mind it can be called directly proportional, okay? Varies proportionally, okay, means the same thing. Okay, so now we have an example of an inverse variation word problem, okay? The time it takes to get to campus varies inversely as your driving speed. So right here I would think y is equal to k divided by x. There's our inverse variation. The time it takes, I'm going to let t be equal to my time. It varies inversely as your driving speed. Okay, so there's my speed. So now I'm going to take my output is my time, and it varies inversely with the speed. So instead of y is equal to k divided by x, I've got t is equal to k divided by s. Okay, makes a little bit more sense. So now we're looking at the information. Averaging 20 miles an hour in bad traffic, so the speed is 20 and the time is an hour and 1.5 hours, okay? So the time is 1.5 and our speed is 20 miles an hour. So to figure out our K, we just multiply 1.5 times 20, and we're going to get, oops, actually, I'm sorry, that's 30. We got 30. Hold on a second. So we multiply these two, that's right, and we get 30. Okay, 20 times 1.5. So our K is going to be 30. So we're going to rewrite this as the time is going to be equal to 30 divided by the speed. Okay, so there's the equation we're going to use. All right, and now it says, how long would the trip take averaging 50 miles an hour? So now our speed has changed, or at least set to 50 miles an hour. Set at, let x be equal to 50. So we just plug it in. So our t is equal to 30 divided by 50, which is 3/5, which is 0.6 hours. Okay, and all the steps are up here as well. Okay, so let's try some. All right, a man has to take a bus to and from work each day. The cost in dollars, okay, varies directly as the number of days he commutes. So the cost, okay, varying directly. Okay, first let's do y is equal to k times x. Okay, and the cost, let's let c be equal to the cost, the total cost, and d be equal to the number of days. Okay, now this one's a little bit different because it says it costs him $3 per day. Okay, so per day is not the total cost, it's actually the rate of change, or in this case, it's our K. So they're telling us the K, the constant of proportionality. So our K, we don't need to figure it out, is actually 3. Okay, so if it costs him $3 per day in bus fare, how many days does he commute if it costs him $36? So now our cost is going to be equal to K times the number of days. All right, so in this case, the cost is equal to 3 times the number of days because it's costing $3 per day. And it's going to cost him $36. So how many days is that? All we have to do is divide by 3, and we're going to get, okay, and we're just going to get the 12 days. So 36 divided by 3 is 12. So 12 is D, so we have 12 days. Okay, this one was a little bit different, okay, because we were given the K. Usually we're going to have to calculate the K, or the constant of proportionality. All right, the amount of money, number 2, earned on a job is directly proportional. Directly proportional. Y is equal to K times X. The amount of money, so I'm going to let M be my money, is directly proportional to number of hours. So there's my let statement. And now instead of using y is equal to kx, my money in this order is proportional to the hours, okay? If $36 is earned for 8 hours of work, so now we're trying to figure out the k. So the money is $36 and it's 8 hours of work, okay? So to solve for k, we actually just divide by 8, okay? And our k in this case is going to be $4.50, or 4.5. Excuse me. So we've got k is equal to 4.5. We take that 4.5 and we plug it back in. Money is equal to 4.5 times the number of hours. And the question says, how much is earned for 30 hours of work? So we just let our h be equal to 30 and we plug it in. We're trying to figure out the money. 4.5 times 30. And that's going to be equal to $135. Okay. All right, let's look at number 3. The planting time T, so there's our let statement. They're giving that to us. T is time. Varies inversely. Varying inversely. Y is equal to K divided by X. Our output is equal to the constant divided by X, okay? And it varies inversely with the number of people. So P is equal to the people. All right, so let's take our inverse variation equation and use T and P instead. So in order, the planting time is the output, okay, varies inversely with the number of people. Okay, so now the word problem is giving us information. The group estimates that 20 people, so our P is going to be 20, and 20 people working for 200 hours. So our time is 200. And it's going to take them to get all the flower beds planted. So we first figure out the K, the constant of proportionality. All right, so 200 is equal to K divided by 20. We just plugged in our T and our P. We calculate by multiplying both sides by 20, and our K is going to be equal to 4,000. Okay, so it's like it takes a total of 4,000 man hours. Okay, so that's what we do when we plug it back in. Okay, the time is going to be 4,000 divided by how many people. Okay, so there's the equation. So the second part says the part here says find the total time it will take a group of 32 people. So we're just letting P be equal to 32 and plugging it in. So the time would be 4,000 divided by 32. The time would work out to be 125. And don't forget your units. It would be hours. Okay. Moving on to the next one, the number of calories in a carton of milk is directly proportional. Remember, directly proportional is the same as a direct variation. So y is equal to k times x. Okay, the number of calories is directly proportional to the amount of milk in the carton. So let's let C be the calories. All right, and let's let A be the amount. Okay, you can use your own variables. Keep yourself organized. So the calories would be proportional to the amount of milk. Okay, and you could use M there. Okay, if there's 160 calories in an 8-ounce glass, so the calories would be 160. Okay, in an 8-ounce glass, the amount is 8. We just divide by 8, and we find out that we've got our K is 20. So there's really 20 calories in each ounce. Okay. Direct variation, we plug it in, K is equal to 20 times the amount. It says find the number of calories in a 15-ounce glass of milk. So it's $20 per ounce, so we're just going to take the calories and multiply 20 times 15. Okay, our A is 15, and we find out that our total calories would be 300. Okay, all right, and then number 5. A theater company plans to hire people to build a stage set. The work time T in hours per person varies inversely with the number of people P hired to work. So an inverse variation, y is equal to k divided by x. Okay, we're going to let T be the time and P be the people. And since time is varying inversely with the people, we'll set it up like that. Okay, now the information the word problem gives us, the company estimates 25 people, so our P is going to be 25, are working for 300 hours, and our time is 300. So we're going to plug these values in. We get 300 is equal to K divided by 25. We multiply both sides by 25, and we end up with our K is going to be equal to 7,500. Okay, so once we have that constant of proportionality, we plug it back in here. Our time is equal to 7,500 divided by the number of people. How long will it take the company if the company hires 30 people? So now our P is going to be equal to 30, and all we do to figure out the time is plug in that 30, and we're going to get time is going to be 250 hours. Okay, so in this case, the more people you have, the less time it takes. It's an inverse variation. Okay, I hope that helped. If you need help with the homework, try the homework help video. Thanks, bye.